You are given an integer array where two integers are present only one time and all other integers are present two times. If you see this array, 1 is present two times, 2 is present two times, 3 is present one time and 5 is present one time. So the answer would be 3 and 5. To solve this problem, we need to see an interesting property from XOR. If you do XOR with same number, result would be 0. If you do XOR with 0, then result would be the same number. Let's see what happens if I do XOR of all elements in the array. 1, 2, 1, 3, 2, 5. XOR of 1 and 1 would be 0, 2 and 2 would 0, and 3 and 5 would be, let's say, 3 XOR 5. 0 and 0 would 0, and 0 and 3 XOR 5 would become 3 XOR 5. In binary, the result would be 1, 1, 0, 0 and 1, 0, 1, 0. If you do XOR, this is 3, this is 5, the XOR would be 0, 1, 1, 0. With this XOR value, how can you separate 3 and 5 out of it? If you think more, you can divide this array into two groups. One group would contain 3 and another group would contain 5. In group 3, what number should we put? Let's write binary of each number. We have 1, 2, 3 and 5. The binary of 1 would be 1, 0, 0, 0. The binary of 2 would be this number. Binary of 3 would be 1, 1, 0, 0. Binary of 5 would be 1, 0, 1, 0. If you look at closely, we have second bit set in this number. This is 3 XOR 5. If you see which numbers are having second bit set, 2 and 3. Which numbers are having second bit as 0, 1 and 5. Now what you can do is, you can put all the numbers whose second bit is set in group of 3. 2 is having second bit set, so 2 will be present here. 2 has come 2 times, so we'll put here 2. And 1 is having second position as 0, so we'll put 1 inside group of 5. If you do XOR in group 1, then what will happen? 2 and 2 will become 0. XOR of 3 and 0 would become 3. So result would be 3. Here 1 and 1 will become 0. 5 and 0 will become 5. So answer would be 5. So at the end, we'll be having two numbers, 3 and 5, which is our answer. The main idea here is that we have to find such a rule where we can separate out 3 and 5. How can I say that I have to divide this array into two groups on the basis of second position of the bit? If you see binary of 3 and 5, it is 0, 0, 1, 1. Binary of 5 would be 0, 1, 0, 1, and its XOR would be 0, 1, 1, 0. Because we already know that XOR of same digit would be 0 and XOR of different bit would be 1, we can guarantee that XOR at any bit is having set bit. It means that the first number is 1 and the second number is 0, or the first number is 0 and the second number is 1. On basis of this, we can say that either 3 or you can say x is having set bit or y is having set bit. Both cannot be having same bit. That's why we can put both numbers in different group, and in result all other elements will also be present in either this group or this group, because all other numbers are repetitive. So if you take a and if its second bit is set, then another a will also be having second bit as set. If you take b and if its second bit is not set, then another b's second bit also not be set. If you take c, its second bit is set, then another c's second bit also be set. Why we have taken second bit here? Because we know that if we choose second bit, then it is guaranteed that the number, suppose x and y, it would be falling into two different groups. The solution to this question would be pinned into comment section. If you have any doubt, please comment in comment section. I will reply to it. Let me know which question do you want me to discuss next. Until then, thank you.